All right, continuing on with our tools for geometry, the basics and foundation. We talked about points, lines, and planes a bit. Now we need to talk about line segments and distance. What I want you to do is I want you to go ahead and pause it. I know it's early on. Go ahead and pause it. I want you to do this warm up on your own. We have covered solving for x in class. We have covered doing Pythagorean theorem. Okay, making sure seeing here, if you need to, split it and then start following your steps to isolate x. And then with Pythagorean theorem, remembering that c is across from the right angle, using your a squared plus b squared equals c squared. Okay, the work is about to pop up. Please take a second, go pause the video. With this, we need to move our variables first. That's always suggested. I suggest move the variables first and move the larger variable. And then we need to get, once we did that, we got 14 equals 2x minus 8. Now we need to get the constant away from that variable and coefficient. So we move it, do the opposite operation, get it to the other side. Then we need to get rid of the coefficient in front of the x. In this case, it's multiplying, so we need to divide both sides, and we get 11. But Pythagorean theorem, go ahead and pause and work on this on your own, and then resume and check your answer. With the Pythagorean theorem, there are always 3 steps to Pythagorean theorem. The first thing you're going to do is you're going to square the 2 numbers you have. The second step, you're either going to add or subtract, depending on what you're looking for. In this case, we're looking for the hypotenuse, the bigger side. We want to make the number bigger by adding. And then the last, third, final step is going to be square rooting. We are rounding to the nearest tenth here. All right, so let's get into these line segments. Unlike a line segment, most often referred to as just a segment, it can be measured because it has 2 endpoints. And the endpoints are also used to name the segment. Okay, with a line, you can pick any 2 points you want. With a segment, you cannot, because the 2 endpoints tell you where does it start and where does it stop. So here we're going to name the line containing N and B, points N and B. So again, with this, we have so many different options. You can use any 2 points, points on the line. So let's just say, okay, A and B with that symbol above it. Always make sure you have that line symbol. Now, when you name a segment, it's going to look like a segment. Just like the line, the symbol above it's going to look like the segment. Just like a line symbol looks just like the line. A segment, if we're going to use N and B, segment NB is going to start here and it's going to end here. So what it's going to look like without the line is this. No arrowheads. It starts at N, it ends at B, or it starts at B and ends at N. You don't have as much freedom to name it. You have to use the 2 endpoints. The little bit of freedom you have, it doesn't matter whether you call it segment NB or segment BN. That does not matter. And the line above it is this. You don't put the points on it, but the line symbol has the arrowheads, the segment does not. You can also call this segment BN if you would like to. Okay, so getting used to knowing that. So we can measure these and find distance between them, and we're going to go ahead and talk a little bit about here. Right here on this line, in this example right here, point N is between. Now, I want you to highlight that because you're going to see this a little bit later where a mixed practice, you're going to be looking for certain words to tell you what to do, what, kind of formula-like thing to do. N is between points A and B, if and only if A, N, and B are collinear, so they're on the same line, and then you wind up, if you take AN plus NB, it equals AB. So what this is all saying is we're taking this line, okay? N right here is going to be between A and B. We can see that, right? So this whole AN, NB, AB thing, without the symbols above it, it means a measurement. It's going to be a number. With the symbol, it is a physical thing, okay? A physical, tangible thing. Without the symbol, it means an actual number, measurement. So here we're saying the distance from A to N, if we take that number, we add the distance from N to B, we're going to wind up with the entire distance from A to B. Okay, and this is what we call the segment addition postulate. It's going to be the whole segment is equal to the sum of its parts. What I always like to say here is part plus part equals whole. You take one part, you take another part, it equals the entire thing when you add them together. Okay? And over here, let's go ahead and let's write segment AB with the symbol above it. I said this earlier, name of segment. AB without it is the length of segment. Put in parentheses, this will be a number. Very important, so you know what we're talking about and you can communicate with us, okay? We need to remember that the segment bar means a physical thing. Without the bar means we're looking for a measurement or a number. All right, so let's go ahead and get into segment addition postulate here. So what we're going to do is go ahead and we're going to take this and we're going to find EG. So EG is going to be this entire length. So what we need to do here is we need to take the part plus the part to equal the whole. I use PP and W. So what's happening here is your part plus part equals whole. One part is the length of EF. Remember, no bar means the length, the number, plus FG will equal the entire segment from E to G. So let's go ahead and plug in. I'm going to go ahead and I'm going to convert these to decimals just because it's easier for me, 2.75. And that one is 2.75 as well. So we take part EF, 2.75, plus the other part, FG, 2.75, and it equals, so now we just add them together. This is going to equal your EG. So add them together, and we're going to get 5.5. Over here, let's take a look if we have one part, but we don't have the other. Here we've got part plus part equals whole. So we have, with our, let's do it over here, our part plus part equals whole. Part is AB, plus the other part, BC, is equal to the entire whole segment, AC. Plug in AB, we don't know. So we could just leave it as AB, or X if you'd like, plus BC right here, 5.8, is equal to AC, the 13.2. So just as if you put an X in, cool. But all you're doing here is you're just solving for AB, isolating it. So we subtract the 5.8 from both sides. We're left with AB equals 7.4. Good to get in the habit of outline or boxing and circling your answers as well. All right, let's throw some algebra in here as well, as they did not give us a picture to look at. Please draw it, okay? Because you need to start practicing how to draw this. First, we're seeing find x, y, so we're going to have to substitute back in. If y is between, again, this will make more sense when we get into the next notes, between x and z. So let's draw that. We're going to have x and z, and y is between it. Now, I generally will draw it off, make sure it's very obvious it's not in the center. Again, make more sense later. I make sure you can tell it's definitely not in the center. Here we have that xy right here is 3a, and we have that xz, the entire thing, is 5a minus 4, and yz from y to z right here is going to be 14. All right, so here is your part and the whole. So I'll just jump straight to P part xy plus the other part yz equals the whole entire segment of xz. So let's go ahead and substitute in. xy was 3a plus yz was 14, all equal to xz, 5a minus 4. At this point, we need to solve for x, and then we are going to substitute in for, here they want xy. Go ahead and pause the video and solve for a on your own, please. Here we go, solve for A, we should have gotten 9. So now this is also important. Usually I highlight what it is we're looking for if it's solving for X or actually substituting in, but I want to make sure we had that between highlighted. You need to go back and ask yourself, what did they ask us to find? They've asked us to find XY. So when we looked at XY, we were told that it was 3A, so we need to remove A, and we need to substitute in what we found A to be, which was that 9, okay? And all we have to do in this case is going to multiply, and 3 times 9 is going to give you 27. Okay, so now let's talk about the next part. Why was, well, we'll get into that, I'm sorry. I'm getting ahead of myself here. All right, if we have two geometric figures that have the same shape and same size, we already know same shape, same size is going to mean congruent, okay? If we have a rigid motion and transformations, we just got done with, okay, the pre-image and the new figure called the image are going to be congruent. Likewise, if we have one segment that can be mapped onto the other in a rigid motion, okay, in this case it almost looks like we can just like kind of flip it over here, then we're going to have congruent segments. We will get more into congruent segments later on about solving and figuring out their measurements, but here what we need to understand is that we already talked about, okay, right here A, B, and CD, that's talking about the actual measurement. AB is 10, CD is 10. Over here, again, with the segment bar above it, this tells us that this is the actual physical segment here, and CD as well. When we deal with this, what ends up happening is your measurements are going to be equal. So when we don't have the segment bar, we're going to have an equal sign. So measurements are equal sign. Your segments will be congruent. So it's like the equal sign, but you know, we threw the segment bar above the A, B, and CD. We're going to throw something above the equal sign, a little squiggly line. So here we will have segments are congruent. Very important to remember. I mean, everything we're learning here is very important to remember. Okay? So now we're going to start looking at how to find the measurement of a segment. We're just looking at a single segment if it's on a graph, okay, using the coordinate points. So here the distance between the 2 points, we can use Pythagorean theorem, and we kind of look at the formula and see, all right, so if we have this, we need to figure out, all right, the length right here from, what is that, C to B, we need to figure out what that is, and we know that we would end up, this would be our, we take that and square it, and we take the length of AC and square it, and that would be equal to AB squared. Now, to find the length of CB, we need to subtract, because it's along the x-axis, we need to subtract the x-coordinates. So here we go. We have those x-coordinates. And then to find the length of AC, it's along the y-axis, so we would subtract the y-coordinates of those two. So taking all of this, we can derive this as your Pythagorean theorem, and if we go ahead and get rid of that square root next to C, we can just square root over the entire A squared plus B squared, and that's where we get this, okay? Got rid of it. Now A, looking here, we need to put this formula in, x2 minus x1, and then same thing with B. So that comes down to this formula. This is a very important formula. On your formula chart that we are providing you, underneath coordinate geometry, you're going to see distance formula. This is what we're using. So we are finding the distance. Okay, so we're looking at distance formula. Now, when we go through this, I'm going to go through showing you guys how I like to do this, because, and I cannot stress enough how important this would be. When you use this, we have an x2, x1, y2, y1. If you mix them up and accidentally do x2 minus x1 and then y1 minus x2, whoa, you're going to end up in trouble here, okay? So let's take a look at, there's several of these different formulas we're going to have that are going to be doing that. What I do is we're going to find the distance of these, between these, using the distance formula. I labeled as x1, y1, just the first point up there, name it x1, y1. The second one, I'm going to name x2, y2. And then I know what to substitute into my formula. So let's go ahead and take a look using this. And I usually do this with a radical square root sign at the end because I don't know how long it's going to be, but even if you don't, we can extend it. We're going to open parentheses. We're going to put in x2. Where's my x2? Oh, it's the 5. Cool. We're going to subtract x1. Go find x1. Oh, it's a -4. You need to put -4. Do not just put 5 minus 4, two completely different things. Guys, this little 2 is so little, but it is very powerful. Do not forget your square. We're going to add, open next set of parentheses, find y2. y2 was -1. We're going to subtract. Go find y1. All right, -6. So subtract a -6. We will close out the parentheses and the square. Okay, yes, you can do it all on the calculator at once. I would be very, very careful about that, though. Very careful. You accidentally do something wrong in here, and the entire answer is wrong. So let's go step by step because we also need to talk about this. Step by step, let's go ahead and do our parentheses. 5 minus -4. Well, 5 minus -4 is going to give you a 9. Notice I'm putting in parentheses. Please put it in parentheses still. Okay, trust me. We're going to get to a problem, the last problem. We're going to see what's happening here and why we need to put it in parentheses. The next one, -1 minus -6 winds up giving us a +5 squared. Now I'm going to square the two numbers. Keep that radical square root sign there. 9 squared is 81, plus 5 squared is 25. Let's go ahead and add these together, and we'll get 106. It does say leave in radical form, so we're not going to plug the square root of 106 in the calculator. We're going to leave it as such. Number 4, we're going to find the distance using Pythagorean theorem, leaving it in radical form. So I would say 3 steps to Pythagorean theorem. Square the two numbers, add or subtract, and then square root. We're going to leave it in the square root form. We're not actually going to take that third step. So here we have point C. Let's go ahead and get that on there so we can figure out our measurements, -4, -6. Point D is going to be at +5, -1. And we want to find this distance right here. Do not count diagonally. You are not allowed to count diagonally. Never, ever, ever, ever on a graph are you allowed to count diagonally. This is why we need to use our Pythagorean theorem. If we use a squared plus b squared equals c squared, a and b are going to be the legs, the vertical and the horizontal lines that create that 90-degree angle. These are going to be the legs here. So we can count, all right, how many units do we have here? Our vertical line, we have 1, 2, 3, 4, 5. So this is 5 units long. When we take a look over here, we count 1, 2, 3, 4, 5, 6, 7, 8. It's going to end up being 9. So now we have our A and our B. So we plug in. Doesn't matter which one's A and which one's B. So now we're just going to take the first 2 steps. Square the two numbers, 25 and 81. We're looking for the bigger side, so we want the bigger, so we're going to add, as it tells us to. We're going to end up with 106 equals c squared, and then we're going to take the square root, and we're going to leave it as such. So here, CD, the length of, there we go. The length of the diagonal here is going to end up, we're just going to leave it as the square root of 106. All right, so on the next one, we are going to, unlike number 3, we are going to go ahead and put it in the calculator and round to the nearest tenth. 10 has 1 0, one number after the decimal. All right, let's take a look here. Let's go ahead and we're going to use the, if we're going to find the length of MN, the distance between M and N, with the endpoints. Let's go ahead and start off with labeling X1, Y1, X2, Y2. So we can plug this into our distance formula that we have at the very, very top here or on your formula chart. All right, we start off with, we have our radical sign. We want x2, -3, minus x1, 2, close the parentheses and square, plus y2, open those parentheses, -2, minus y1, 4, close parentheses and square. This is why you need to keep those in parentheses. After you perform what's in the parentheses, leave the number in there and the exponent outside. The next step we end up with here, Negative 3 minus 2 is a negative 5. Leave it in the parentheses. And then here we're going to wind up with negative 6 squared. If you plug into the calculators that we have at the school, if you plug in negative 5 squared in the calculator, it's going to come out as negative 25 because it does order of operations. If you have negative 5 squared here, what it's telling you to do is do the exponent first and then multiply it by an invisible negative 1. It's going to do exponents, then multiplication. So you have to have that in the parentheses. Another rule of thumb, every single number you square is going to be positive, whether it's negative or positive. So in reality, all you need to do is just take the number behind the negative, just square that 5. Okay? So here, negative 5 squared will give you 25. Negative 6 squared, positive 36. And then we add those together to get the square root of 61. When we plug this into the calculator and round to the nearest, I don't want to draw on that, round to the nearest tenths, we're going to wind up with 7.8. And there's your final answer. So make sure you're practicing this distance formula. Please be labeling x1, y1, x2, y2. It makes a world of difference and makes the distance formula a lot easier.